Hi guys, I'm back with an update. I think so. I talked in my previous post that I'm either gonna try to like make an AI learn how to walk or make him drift. So I decided to go with the drifting thing because this is something I was interested in. So over the past 2 3 days, I've made the initial environment for the AI to train in. So the environment is pretty simple. Like you have some turns here. Wait. Yeah. You have some turns here and this part, so like he learns how to go straight as well, and like a circular track here as well, so he can drift and stuff. So this is like a bit complex one. This is not what I'm gonna start with. I'm gonna make it a bit more simple, I have less walls and stuff. My first initial goal would be to make him just learn how to drive. And that's pretty much it. Uh, for the raycast, I decided to go with the 360 view because this is usually what autonomous vehicles use as well. They have a 360 view of the surrounding. So so yeah, if I could show you the raycast. So if you go here, so you can see it can only see two things: walls and targets. The targets, basically I'm gonna spawn them on the go when an episode starts. I'm gonna spawn them. I'm gonna show you guys in a bit as well how it works. And this is the setting for the raycast. I decided to keep these minimalistic, not too much, because they start lagging the PC a lot. So I wanna train 50 100 environments at the same time. So that's why I kept them simple. So yeah, this is pretty much on the raycasting. So I have a game manager that would be basically responsible for spawning the targets and spawn points. So instead of making the targets random, I decided to make the spawn points random, so there's no biasness in the target in the AI. He doesn't learn a specific he doesn't encounter the specific behavior too many times. So I decided to go with that approach instead of randomizing the targets because that would be tough, with the walls and stuff. So I decided to make it simple. And I have this little thing here that would show, if the episode was successful or not, or if he was able to get to targets or not. Targets or not. So I'm gonna show you guys the scripts, how it works. And I want to talk about the problems as well. Some of the problems I faced was for some reason, I made a separate AI script for the car controller, and I don't know why my agent just started floating in started floating So after a couple of hours of debugging and stuff, so I just noticed something the colliders, they weren't working correctly with the other script. So I decided to go with the original script and make the modifications in that. So I want to show you guys the problem. It actually looked quite funny. You could see it was just stuck there. So that was that took me a while to figure out what's wrong with it. And another problem I faced was when I ran multiple environments together, then if one of the agent, if he would collide with the wall in his own environment, that would reset the whole all of the targets in all of the environments. So that was a bit hectic to figure out as well. It took me a while, and finally I figured out a hack. So before, my targets were inside each of these game objects, separately. But then I move them into the game manager, and the game manager manages it locally in a way, if it checks it's the parent, if the target is within that environment or not. If it is, and then it resets it. If it's not, then it will. So that took me a while to figure out as well. I think so, 2 3 hours or something like that. I'm not sure, but it took me a whole night to just make this environment. So talking about the script, I wanna show you guys how the script works. So if you go here, script AI drift. So this was the initial script for it, but I told you guys my colliders weren't working with it for some reason. So I just decided to skip it and just use this instead, like, use the car controller script instead. So this car is basically like an asset out of Unity store, Pomity or something. I use it for one of my game dev modules, so I thought like, I'll use it here as well. So car controller, yeah. So this is a script. This is a script. This is a quite big like script. Like this is not important because this was like already in the script. Like I didn't design it. So let's just move past it to the important bit, like the AI bit of it. So yeah, I think so. It starts from here. Uh, this is pretty much simple. I initialize the rigid body of the thing on episode begin. I basically select like a random spawn point from the environment script. If we go back here, where are the scripts? Yeah, yeah. So yeah, this is the environment manager. Like it manages everything from spawn points to the target. So get random spawn points. Yeah. So basically, it gives us like a random spawn point based on of the spawn points list we already initialized here, and it basically shows like the location of all the spawn points. So we get that. We initialize like agent there. Like we set the local position and rotation of it. The velocity, angular velocity, we set it on to 0 at the beginning of the episode. That's nothing much. And like we reset the steering angle as well. Like if like at the moment, like when the agent ended the episode, right, he could be turning right to left. So reset back the steering angle as well. And I take the throttle off as well. For instance, if he was accelerating or something, it just goes back to 0. And we reset the environment as well. So if we go here, reset environment basically just removes all the targets, like the previous targets we had in the environment. As I told you guys, like this was something I had to figure out like eventually, because like it would reset every target across all the environment. So I just made it in a way like it would do it localized inside that environment specifically. Last time is basically I don't use it at the moment. Like I'll use it like in the later stage. Like I'm gonna give it like a time to complete the stage in. So to incentivize like the agent a bit more. So like he's confident in making his decisions and stuff. So these are the observations he gets. Like he gets his velocity. He knows what's his velocity and like what's his direction and stuff. Like which direction he was heading to. He gets his local position, like where he's in the environment, and his rotation as well, and he gets his speed. So like he knows like how to control his speed and stuff, and like whether he's drifting at the moment or not. Because like I want to incentivize the agent for like drifting, right? So like I want to get that behavior out of him, so I'm gonna especially gonna be incentivizing him for that. So I want him to have that information. So this is not getting added as like observation into the thing, but like it sets up the gravity and kinematics for the car rigid body. So talking about the action received, the agent has two continuous actions and one discrete action. Discrete action is being like the handbrake, like if you can drift or not. So these are like pretty simple things, like controlling like the agent movements, like rotation, left, right, throttle, and stuff, like how to handbrake, recover traction, like if you like if you go below a certain speed, like it recovers the traction and stuff. So this is my initial reward function, which I've thought of, like I haven't tested it yet. So like if it's drifting, like if it's drifting, and then we add a reward according to that speed, like how much speed it is at, and add reward for drifting as well. So this is gonna basically like and incentivize him to drift more. um I have a couple of ideas for this. I think so I'm gonna do it time based as well, like in a way, like if he does longer drifts he gets more reward. But this is something I'll explore later, and like I'll make a video about it as well. So this is like for instance, if the car speed is below a minimum threshold speed, like for instance, like if he goes below, let's say 20-30 kilometers he gets penalized for it. So it would incentivize him to like continuously move and drift, and like be confident about his route, decision making when it comes to like avoiding a wall or something like that. So he does it like at higher speeds. This is the heuristic function. I don't think so. I need to go into that a bit. It just sets up the key codes, like what does what for discrete functions, for heuristic or like when I want to control it. So this is like the triggers on target. He gets like a 50 reward, and if it's drifting and hits the target, he gets like an extra reward. So like so he hits the target while drifting, to incentivize that behavior a lot more. And for instance, if he gets all the targets, he gets like an extra 100 rewards, which would basically make him like get try to get more targets, like complete the episode. And on collusion, he gets like minus 30 reward, like if he collides with the wall, to like make sure like he doesn't learn that behavior or something. Talking about the configuration, this is like my basic configuration for the thing. So for instance, like I'm using PPO policy, proximal policy gradient method for this. These are the hyperparameters for it. So I did a bit of research into like what these hyperparameters do. Like for instance, batch sizes, like the number of experiences, for instance, the state action, and things like that used per iteration of training. But the thing is, like with larger batch sizes, I decided to go with like something in between now. But I'm gonna experiment with it. With the thing with larger batch sizes is like it provides more stable updates, but it requires a lot more memory. So I don't have like as I told you, I'm gonna be running 5200 environments at the same time. So that can be a bit computationally expensive, but I'll look into it. Like if there's a way to like make it better. And buffer size is like the number of experience collected before each update, like before like the agents update their policy, right? The number of experiences they collect. So larger buffer size means like at once he's gonna be trained on a lot more data, but which can lead to better generalization. So I feel like my buffer size is fairly normal. I don't think there's too much. Yeah, it is bigger than like previous AIs that I've trained, because this is a bit more complex task, right? So I want him to have more data and stuff. Learning rate is like the like for instance how much change the agent makes in his policy, like how much he updates his weights and stuff. Smaller learning rate is basically a better approach, but it can be a bit more computational and expensive in a way, like the agent can take a lot more time to like learn and stuff. So I decided to go with a smaller running rate. So I don't care about how much time it takes at the moment, but I'll be experimenting with this as well. Beta is like it is for entropy regularization, like how much like randomization you want in like in the agent to select his next move. So I think so. You guys can research into it a bit, but I have done my research into it, like to understand how everything works. For instance, hidden units is like uh, hidden units is like the number of units in each hidden layer. Like you have the first input layer and then the output layer, and then you have hidden layer in between. So like it controls the number of units inside the hidden layer. So I decided to go with 256. Usually I go with 128, but as it is more complex task, right? So I want him to have like better so he can learn more complex representations. That's what I want to say. I don't know what's my brain doing. But and yeah, normalize is like it normalizes every data that is fed into like the agent. Usually like it's not required, but sometimes it can give good results and stuff. So I'm gonna experiment with that as well, and number of layers as well. Like the more complex the behaviors are, it's preferred to have more layers. So I think so. Initially, I'm gonna try to train it for like 10 million steps and see like what kind of like behaviors I can get out of it, and then like I'll try to modify it and produce like a better reward function. So give you to show you guys how the drifting and the mechanics work. So I'm just gonna quickly do this. Okay. So you guys can see like this is kind of like the particle system already built in there. Like if you drift, you can see it. Okay. So you can see this is the kind of mechanics the agent is gonna be working with. So for instance, if you collide with the wall, right? So you get spawned at a random position, and instead of the wall, that decided to go with these. I don't know why they look much better to me. So like and you can see up there like if you collect the targets, you get the yellow indicator up there. So if you go and look at it again and see. So it's red now. So this is like kind of like the signal thing I talked to you guys about. So everything apart from the targets, if the agent touches it, it will reset the episode, and like you can see it can drift pretty easily. And this is something I want the agent to learn, like go through the circles, something like this, like continuously drift through it. And that's pretty much it, I think. So like when it comes to the mechanics of the environment. And yeah, I want him to achieve higher speeds and stuff, so like do something like this, but we'll see how much what kind of behavior I can get out of him. One thing I'm worried about is like he might just learn how to go into like circles, for instance, like drift when you see these skid marks, right? So this is technically setting the is drifting flag true. So I don't know like how the agent is gonna behave to it, but I'm thinking he might learn how to do something like this, like just go into in circles. But to be honest, like this is something of like a drifting thing. So I feel like it would be good in a way, like he would learn how to drift. That I can like penalize him for just wasting time or something like that, and he learns something different. But we'll see. Hopefully, like by in the next 2 3 days, I'll try to run my first training batch and see what kind of results I can get out, and then I'll share with it. And that's it. I think so. Bye bye.